Another probable question from module 1 is explain equality of cross shear. It can also be asked as prove that the cross shears are equal. In order to prove that cross shears are equal, let us consider an element of sides dx, dy and dz. So this is a rectangular element or a block like this. Okay. Now I am marking the shear stresses on the opposite faces. Okay. The vertical faces. Next I am marking the shear stresses on the horizontal faces, both top and bottom faces. Now we are only considering one pair of stress in parallel faces or parallel planes, these two. Okay. Let us consider that the shear stresses on the front and back vertical faces are 0. So now let us consider the equilibrium of the element. For that, I am marking a center point of this element as A and taking moments about the point A. Okay, for equilibrium, sum of moments about A should be equal to 0. A or any point, it can be any point. So here we have 4 stresses acting on 4 faces. We need to find the corresponding shear force and find the moment about A. So let us take this stress tau xy. It will create an anti-clockwise moment and it is acting on an area dy into dz. So this will cause an anti-clockwise moment, so I put negative. Now the distance, perpendicular distance of this shear force from A is dx by 2. Next let us consider the shear stress caused by this stress element, and it will create a clockwise moment, so it is positive. It is acting on the area dx into dy, and the perpendicular distance from A to that shear force is dz by 2. So I am multiplying it with dz by 2. Next let us consider this moment. That will be an anti-clockwise one, so I am putting negative sign. The shear stress is tau xy and the area on which it is acting is dy into dz into the distance is dx by 2. Okay, and it will create an anti-clockwise moment. Next one is a clockwise moment, that is the shear force corresponding to the shear stress in the base plane. Okay, tau yx, that is acting in an area dx into dy, and the perpendicular distance is dz by 2. So it's equal to 0. Sum of all these is equal to 0. So adding the first and third components, we'll get minus 2 tau xy into dx dy dz by 2. Then adding the second and fourth components, we get 2 into tau yx dx into dy into dz by 2 is equal to 0. Here 2 and 2 cancels. Then dx dy into dz is also will also get cancelled. So rearranging these, cancelling out the common terms and rearranging this, we get the equation as equal to tau xy is equal to tau yx. And this proves that cross shears are equal.